Look up on a clear night, and you are staring into deep time. The light in your eyes has traveled for thousands, even millions of years to reach you. Everything you see, every star, every galaxy, the atoms in your own body, has a single origin. A beginning so strange it barely sounds real. To tell it, we have to go back further than the first human, further than the first life, further than the earth and the sun. All the way back to the beginning of time itself. This is the story of the Big Bang, how the entire universe erupted from a point smaller than an atom, and became everything that is. 13.8 billion years ago, everything that exists was compressed into a single point, hotter and denser than anything we can imagine, smaller than a subatomic particle. There was no space around it, and no time before it. Space and time did not yet exist. The Big Bang was not an explosion in the void. It was the sudden birth of the void itself. In the very first instant, the universe was so extreme that our known laws of physics simply break down. We can describe what came next, but that first flicker remains a mystery. And then, in less than a trillionth of a second, everything changed forever. At just 10 to the minus 36 seconds, the universe did something almost beyond belief. In a sliver of an instant, it ballooned in size by a factor of a trillion. This is called inflation. A region far smaller than a proton was stretched larger than a galaxy, expanding faster than light, because it was space itself, not matter, that was growing. Inflation smoothed the infant cosmos, ironing out its wrinkles until it looked nearly the same in every direction. It is why the universe today is so astonishingly uniform. But it left behind something priceless, tiny quantum ripples, frozen into the fabric of space. Those faint ripples would one day grow into every galaxy in the sky. As inflation ended, its titanic energy poured into a boiling soup of the most fundamental particles, quarks, gluons, and electrons, at more than 1 trillion degrees. Matter and energy were the same thing, flickering back and forth. Out of pure energy, particles and their antimatter twins appeared, collided, and vanished in a storm of light. This was the fireball of creation, the hottest the universe would ever be. Everything that would ever exist was here, waiting in this raging sea of energy. Here the universe faced a crisis. Matter and antimatter destroy each other on contact. If they had existed in perfect balance, everything would have annihilated into pure light. But nature cheated, just barely. For every billion particles of antimatter, there were 1,000,000,001 particles of matter. A surplus of just 1 in 1,000,000,000. When the great annihilation came, that tiny leftover fraction survived. Everything you have ever seen or touched is built from that 1 in 1,000,000,000 remainder. Why matter won this war is one of the deepest unsolved mysteries in all of physics. But because it did, we are here. One full second after the beginning, the universe had cooled just enough for quarks to bind together in threes, forming the first protons and neutrons, the future cores of atoms. The cosmos was still a searing plasma, far too hot for any atom to survive. But the raw material of all future matter now existed, glowing in the light of its own heat. Between 3 and 20 minutes in, the entire universe became a nuclear furnace. Protons and neutrons slammed together and fused, in a process called Big Bang nucleosynthesis. In those few minutes, the cosmos forged its first elements, hydrogen, helium, and a trace of lithium. It fixed the recipe of the universe, roughly 3/4 hydrogen, 1/4 helium. Then, as fast as it began, it stopped. The universe expanded and cooled too much to fuse anything more. For the next 380,000 years, not a single new element would be made. Every heavier atom, the carbon in your cells, the oxygen you breathe, the iron in your blood, would have to wait for the stars. For hundreds of thousands of years, the universe was an opaque, glowing fog. Light could not travel, it bounced endlessly off a dense sea of free-flying electrons. If you had been there, you would have seen only a blinding, featureless glare in every direction, like being trapped inside the surface of the sun. No stars. No shadows. Just light with nowhere to go. The universe was expanding all the while, and slowly, inevitably, cooling. And as it cooled, it approached a moment that would change everything. 380,000 years after the beginning, the universe cooled to about 3,000 degrees. At last, electrons slowed enough to be captured by nuclei, forming the first complete atoms. In that moment, the fog lifted. Suddenly light could stream freely across space for the first time. The universe became transparent, and it has stayed that way ever since. That first freed light is still traveling today. Stretched and cooled by billions of years of expansion, it fills the entire sky as a faint microwave glow. We call it the cosmic microwave background, the oldest light in existence, a literal baby photograph of the universe, taken when it was less than a millionth of its current age. And printed across it are those tiny ripples from inflation, the seeds from which everything would grow. But with that first light released and fading, the universe fell dark. There were no stars, no galaxies, only cold, invisible clouds of hydrogen and helium drifting in blackness. For tens of millions of years, this was the cosmic dark ages. A vast, silent, lightless universe, seemingly empty and lifeless. Yet something was working in that darkness, patient and relentless. Gravity. Guided by the invisible pull of mysterious dark matter, the gas began to gather. Slowly, over millions of years, it pooled into ever denser knots, pulling inward, growing hotter at their hearts. Around 100 to 200 million years after the Big Bang, deep inside the densest cloud, the pressure and heat finally crossed a threshold. Atoms fused. And a star ignited. For the first time in the history of the universe, there was a sun. A single point of true starlight, blazing in a cosmos that had never known one. This was cosmic dawn, the moment the long darkness ended. And soon it was joined by another star, and another, until the void was sprinkled with fire. These first stars were monsters. Made of pure hydrogen and helium, they grew hundreds of times more massive than our Sun, burning blue-white and impossibly bright. They lived furiously and died young, shining for only a few million years, racing through their fuel where our Sun will burn for 10 billion. And deep in their cores, under crushing heat and pressure, they did something no process ever had before. They forged brand new elements: carbon, oxygen, silicon, iron. The atoms that would one day build planets, oceans, and living cells were being created for the very first time, inside these dying giants. When these giants finally ran out of fuel, they did not fade quietly. They collapsed and detonated as supernovae, explosions so violent they briefly outshone entire galaxies. Each blast tore the star apart and hurled its precious cargo of heavy elements out into space, seeding the surrounding clouds with the ingredients of worlds. Death, it turned out, was creation. Every supernova enriched the cosmos, so the next generation of stars could be born with planets and with possibility. The iron in your blood, the calcium in your bones, all of it was forged in a star and scattered by an explosion like this, long before the Earth existed. Stop and consider what this means. Every heavy atom in your body was forged inside a star and flung across space by an explosion, billions of years before you were born. The calcium in your bones. The iron in your blood. The oxygen in every breath. All of it was cooked in the hearts of ancient suns that died so that you could exist. We are not separate from the universe, watching from the outside. We are made of it. We are the cosmos, grown complex enough to look back and wonder where it came from. Stars did not drift alone. Pulled together by the gravity of dark matter, they gathered by the millions into the first galaxies, small, chaotic, and blazing with newborn suns. These infant galaxies were fierce, bursting with star formation, colliding and merging in the crowded early universe. With every collision, they grew. Over billions of years, these mergers would build the grand, majestic spiral galaxies that fill the cosmos today. At the center of these young galaxies, something terrifying was growing. Giant black holes formed and fed, devouring gas and entire stars. As matter spiraled in, it heated to millions of degrees and blazed with the light of a trillion suns. These are quasars, the brightest objects in the entire universe. These supermassive black holes swelled to millions, even billions of times the mass of our Sun. And strangely, they helped shape the very galaxies around them. One such monster sits at the heart of our own galaxy, right now. Silent, immense, and older than the Earth. But there is a secret hiding in all of this. Everything we can see, every star and galaxy, makes up less than a fifth of the matter in the universe. The rest is dark matter, an invisible substance that gives off no light, yet outweighs everything visible 5 to 1. We feel it only by its gravity. It was dark matter that first pulled the gas together in the Dark Ages, building the scaffolding on which every galaxy was hung. Without it, there would be no us. And to this day, we do not know what it is. The universe is mostly made of something we have never seen and cannot yet name. Zoom out far enough, and a hidden architecture appears. Galaxies are not scattered at random, they are strung along immense filaments and walls, wrapped around vast empty voids. This is the cosmic web, the largest structure in all existence, spanning billions of light-years. And its shape was drawn by those faint quantum ripples from the very first instant of inflation, magnified across the entire universe. The smallest beginning became the grandest design. There is one final mystery woven through the whole story. The expansion born in the Big Bang never stopped, and about 6 billion years ago, it began to speed up. Some strange force is pushing the universe apart, faster and faster. We call it dark energy, and it makes up nearly 3/4 of everything that exists. Its cause is completely unknown, perhaps the greatest unsolved puzzle in science. It will decide the ultimate fate of the cosmos, billions of years from now. Among the countless galaxies, one was quietly assembling in an unremarkable corner of the cosmos. Merger by merger, star by star, our own Milky Way was taking shape. It grew into a vast spiral wheel of hundreds of billions of stars, turning slowly through the dark, its arms glittering with the births and deaths of suns. And in one quiet arm, far from the crowded center, the ashes of dead stars were gathering, enriched with carbon, oxygen, and iron. The ingredients for something new were coming together. The ingredients for a star like our Sun, and worlds like our own. 9 billion years after the Big Bang, the universe had grown mature and rich, seeded throughout with the heavy elements of countless dead stars. From a single point of infinite energy, the cosmos had become a sprawling web of galaxies, stars, and the raw material of planets. And in one small cloud of gas and dust, on the edge of an ordinary galaxy, a new star was about to be born. A star we would come to call the Sun. From nothing, everything. From a formless flash of light, a universe of 1 trillion galaxies. This was the birth of everything, and the story was only just beginning.